I thought we'd continue our conversation this morning about energy and the units that we use in energy. And one of those units that we're all familiar with, because most all of us pay our utility bill at our home to our local electric company, is a kilowatt hour. So we want to talk a little bit about what is this thing called a kilowatt hour. And I invite you, the next time you're writing the check or paying online or however you take care of your utility bill, just to glance down and see how many kWh or kilowatt hours you use in that probably anywhere from a 28-day to a 31-day billing cycle. Across America, we use about on the average across the year, we use somewhere between 900 and 1,000 kilowatt hours per household. So if you've got a family, I think that's based upon 4 in a family, something like that. And if we look at the cost of those 950 or 1,000 kilowatt hours, they range as low as 6 cents to as high as 21 cents across the country, with an average being right at 13 cents. So the takeaway from this is the average household in the average month in America has 1,000 kilowatt hours at 13 cents, or your electric bill is $130. Some of you may be paying as little as 60, and some of you may be paying as high as 400, but the national average is just about $130. So let's go back and look at this kilowatt hour that we bought for 13 cents. Just again, trying to get a visceral understanding of how much energy is in this kilowatt hour. Well, one thing we could do is we could say, well, let's buy ourselves a small pump, say a 4 horsepower pump, something that would pump, say, 100 gallons a minute, and it would raise it 100 feet high, 8 or 9 stories high. So the basic, and I'm going to write down a few equations so that you can kind of internalize them. The brake horsepower, this is all engineering stuff, we love it. The brake horsepower for a pump is all we got to do is take the gallons per minute times the feet, or the head in feet, and then we divide that by a constant that converts the gallons per minute into pounds per hour and horsepower hours and stuff, and that number's 3940, and the efficiency of the pump. And pumps range from maybe as small as 40% efficient upwards. When we get really big, high efficiency pumps, they're probably 85% efficient. So that number's 0.4 to 0.9, you might say. So now let's just go ahead and take this 100 gallons a minute times 100 foot head divided by 3940. And let's say the efficiency of our pump's 0.65. Could find some at 0.6, could probably find some at 0.7 or whatever. That's going to tell us that we need about 3.9 horsepower. You know, your car has got 100 horsepower, your lawnmower's got 3 horsepower, so there's kind of a sense as to what a horsepower is. So this is 3.9 horsepower. Another thing to remember, that 1 horsepower is equal to about 750 watts. And back to our kilowatt hour. Okay, a kilowatt hour, right, could be a 100-watt light bulb running for 10 hours. That's 100 watts times 10 hours is 1,000. And 1,000 watts is a kilowatt, and you do it in over an hour, and it's an hour. So it's a kilowatt hour. So now we come down here, and we'll just kind of say that a horsepower is also more or less equal to 1 kilowatt hour. Okay? So now let's see if we ran, this is 4 horsepower. So it'd be 4 kilowatt hours in an hour. But if we only ran it, let's just run our pump 15 minutes. Let's just run it 15 minutes. So let's take 15 minutes times 100 gallons. What's that? That's 1,500 gallons. Well, so in 15, and we raised it 100 feet. Now just imagine you took 1,500 gallons or you took 100 gallons, ran it for 15 minutes, and you raised 1,500 gallons up 100 feet. Well, 1,500 gallons is the same thing as 12,000 pounds. So the takeaway from this is up 100 feet in the air. What you were able to do with this 1 kilowatt hour or 13 cents worth of electricity, you were able to raise 12,000 pounds 100 feet in the air. You were able to do, and 12,000 pounds is 2 small cars. So where else can you do this and raise 12,000 pounds up 100 feet for only 13 cents? So the takeaway from this is really this whole electric thing that we have is a bargain. So you can remember that, wow, because imagine if I gave you 5-gallon buckets, okay? And how many times, well, you'd have to take 500 buckets up to get 1,500 gallons, right? And taking them up 10 flights of stairs, wouldn't you rather pay 13 cents and buy yourself a pump? So again, this kilowatt hour that we just routinely pay for is really a big deal. And we get it cheap, which sometimes doesn't motivate us to conserve as much as we should, but we need to because there's only so much fuel left in the world, and we need to figure out a way to conserve each kilowatt hour that we can. So there's our story about what can you buy for 13 cents worth of electricity.